It is that time, my friend. Time for us, once again, to review a few questions to confirm our understanding regarding OSPF. So with that being said, take one. And our first question is this. Consider the following interfaces on router 5. So we got beautiful router 5 right here. It's got a whole bunch of interfaces with these IP addresses, some physical interfaces, some loopbacks. And the question is right here, what would be the command to bring up OSPF for process 1 on this router, and what would be the OSPF router ID? And to make this perfect, boom, I'll put a question mark right there. So take a moment, give that some thought. We'll compare answers in just a moment. So let's begin with the command to bring OSPF up. And that would be router space OSPF space and then the process ID. So we use a process ID of 1. And then it's asking, once that comes up, what's going to be the router ID? And regarding the router ID, if we went into router configuration mode and we configured it, that would be the router ID. If that's not present, it's the highest IP address on a loopback, which would be this bad boy right there. And if there were no loopbacks, it would be the highest IP address on any physical interface that was up at the time that OSPF was started. So in answer to this question, the router ID would be 10.0.0.65. All right, onward and upward. Question number 2. A router is directly connected to the following networks: the 192.168.1.0, 1.32, 1.48, 1.64 with these respective masks. And the question is, which OSPF network statement would add only the network of 192.168.1.48 with a 28-bit mask, this one right here? Which network statement would add just that network into OSPF in area 0 on this router? So take a moment, pause me, and we'll be back to compare notes in just a moment. So to add this network of 192.168.1.48 with the 28-bit mask in router configuration mode, we type in the word network, good start, space, and then we'd put in the network itself, which is 192.168.1.48. That's the literal network space. And then we need the wildcard mask that's appropriate for a 28-bit network. So if we put our powers of 2 up, 128, 64, 32, 16, 8, 4, 2, and 1, and then we're going for a 28-bit mask. If this is our 24-bit boundary and we're going to 28, it would be 25, 26, 27, 28. There's our dividing line. These would be zeros. So there's the mask in binary, and all we need to do is simply flip that mask to represent the wildcard mask. So if we did it longhand, it would be 0. This would be the wildcard mask here. Here's the mask. It'd be 0, 0, 0, 0, 1, 1, 1, 1, and we could add up those values. 8 plus 4 is 12, plus 2 more is 14, plus 1 more is 15, and our wildcard mask in that last octet would be a .15. So it would be 0 for the first octet, that's the 192, 0 for the second octet, the 168, 0 for the third octet, the 1, and then 15 in that final octet as the wildcard mask. And in the previous videos, we've taken a look at a couple shortcuts that we could use to get to that 15. But the point is, we need to make sure that we can get there and have the correct wildcard mask as part of our network statement. But we're not done, because it also says make sure you add that network into area 0. So furthermore, we'd use the command area space and then the number 0 to go ahead and put that network into area 0. And question number 3. Which of the following are true regarding OSPF on a broadcast-based Ethernet portion of the network? So take a moment, read all 5 possible answers, and identify which of those 5 are true statements regarding a broadcast-based Ethernet network where OSPF is running. So let's tackle this from the top down, starting with A. There will always be DR other relationships. Now, if we have an Ethernet network, let's go ahead and draw one. So router 1 and router 2. That always helps me if I draw something out. So I've got Ethernet right here. In this case, with only 2 devices, one's going to be a DR, the other's going to be a BDR. And unfortunately, if there's only 2 devices there that are routers running OSPF, that's it. There's not going to be any DR others. So if we had more devices on that same network segment, there's the opportunity to have DR others. However, in this scenario right here, the keyword always doesn't apply because there would not be DR other relationships if we only had 1 or 2 routers on that segment. So A is out. All right, answer B. There will be a DR, a designated router, and that is true. There will be. If OSPF is running for that network, there's going to be a device that's acting as the designated router if it's a broadcast-based Ethernet segment that they're on. Answer C says the DR will generate the LSA Type 2 messages. It does, and that's also true. And those LSA Type 2s are describing this network segment and all the other OSPF speakers that are attached to that segment. Answer D says each router will generate their own LSA Type 1s. That's also very, very true. That describes the router themselves and their own links. And answer E says when 2 or more routers are present on a broadcast-based Ethernet portion of the network, there will be a BDR. And that's true. So if we have the first one that shows up would be the designated router, and the second one would be a BDR. So that's true. So answers B, C, D, and E are all true regarding broadcast-based Ethernet segments where OSPF is running. So thanks for joining me in this review of a few questions regarding the concepts of dynamic routing with OSPF. I hope this has been informative for you, and I'd like to thank you for viewing.